This is Humanure Girl. She has come from the future to incite a revolution. The future generations have waited and waited for a revolution to occur. They are watching us through time machine cameras, and fear that if they don't plant the seed of revolution themselves, nothing will evolve on its own. Thus they have chosen the best and the brightest of their rank, and sent her here with the hope that she will spread the knowledge of their success.
What's this? A receptacle for drinking water? Why is it so low to the ground?
Although the future generations have yet to perfect their time-traveling systems, and so the date and location Humanure Girl has been sent back to is entirely random. Luckily, she didn't end up with the dinosaurs. The year is 2015. The location is a small bar bathroom in Madrid, New Mexico.
Wait, I'm on a mission. I'm going to start a composting toilet revolution.
Humanure Girl remembers her purpose and flees to the outdoors, where, to her dismay, she sees that the arroyo is dry and that water is nowhere to be found.
Where's all the water?
Well, Humanure Girl, I know this will be hard to believe, but on this world of about 70% water, only 1% of it is available as fresh drinking water. And of that 1%, the average person in the U.S. uses 150 gallons of water per day. Approximately 27% of those gallons are utilized in toilet flushing, with each flush requiring anywhere from 1.6 to 4 gallons of water. Yes, that's right. Clean water is used to flush urine and poop out of the user's home and out of their consciousness. This absurd contamination of water transforms the resources of urine and feces into wastes. What I'm about to tell you next, Humanure Girl, will blow your mind. You might just want to sit down. For most people, the act of flushing a toilet is habitual and almost without thought. Where are we sending the clean water that we contaminate? Oddly enough, Humanure Girl, we send the contaminated water to places that attempt to purify it and remove the toxins we have just added to it. There are two main systems used in the U.S. for water purification: the septic tank and wastewater treatment plants. 25% of U.S. households use septic tanks. The other 75% uses wastewater treatment plants. Septic tanks consist of an underground tank which black and gray waters flow to. The sewage settles inside of the tank, where the solid material, or sludge, is slowly broken down through anaerobic bacterial digestion. The remaining sewage or effluent then leaves the tank through a series of perforated pipes called a leach field, which drains into the ground. Yet this doesn't ensure total sanitation. Septic tanks are a major source for groundwater pollution, leaching contaminants such as bacteria, viruses, nitrates, phosphates, chlorides, and organic compounds such as trichloroethylene into the environment. Between 820 and 1,460 billion gallons of this contaminated water are discharged per year to our shallowest aquifers. In the U.S., septic tanks are reported as the main source of groundwater contamination. Wastewater treatment plants, or sewage plants, the main form of water sanitation in the U.S., treat household liquid waste similarly to septic tanks. The incoming solution of waste is 99% liquid and 1% solid. This solution undergoes microbial digestion via a process of activated sludge treatment, in which oxygen is vigorously bubbled through the wastewater. The remaining sludge is usually then buried in landfills. The resulting liquid is then treated with chlorine and discharged into a stream, river, or other body of water. Chlorine is a potent poison that kills microorganisms by damaging their cell membranes, which leads to a leakage of their proteins, RNA, and DNA.
That's just ridiculous. Why would you dirty your drinking water just to clean it up again? Don't people realize there are alternatives? Alternatives that turn urine and feces into soil for growing plants. Where I'm from, the problem is the solution.
We practice a closed nutrient cycle in which we grow our food, eat it, excrete it, and then compost it, so that we can return the nutrients to the soil and start the whole process over. The power of composting human manure is awesome. In fact, composting human manure isn't just a wonderful way to enrich soil, but it also prevents pollution by reducing methane production in landfills and reducing or eliminating organic garbage and sewage. It fights existing pollution by degrading toxic chemicals, binding heavy metals, and can clean contaminated air and stormwater runoff. Humanure compost aids in land restoration by helping to restore wildlife habitats and damaged wetlands, reclaiming mined lands, and helping to prevent erosion on floodplains. Additionally, composting humanure destroys pathogens from humans, plants, and livestock. On an economic level, composting humanure saves money because it can be used to produce food, eliminating waste disposal costs, reduces the need for water, fertilizers, and pesticides, and can be sold at a profit. The two main ways to compost humanure are to use a slow low-temperature process or a faster high-temperature process. Slow low-temperature humanure composting requires less user participation and includes many commercial composting toilets. Here at Ampersand Sustainable Learning Center, we use high-temperature or thermophilic composting. Thermophilic or heat-loving bacteria heat the compost pile to temperatures too hot for pathogens to survive, which is well above the human body temperature of 98.6 degrees Fahrenheit. The ideal temperature range is around 113 to 139 degrees Fahrenheit, which is hot enough to kill all pathogens, but not too hot to kill the good microbial diversity of the compost pile. A temperature of 122 degrees Fahrenheit, if maintained for 24 hours, is sufficient to kill all of the pathogens. Microorganisms are amazing! We want to keep the microorganisms happy, so we need to give them a balanced diet of a lot of carbon and a little nitrogen. The ideal carbon to nitrogen ratio is 25 to 30 parts carbon to 1 part nitrogen, but it doesn't have to be an exact science since humanure will still compost outside this ratio, it just takes more time. Human feces and urine are nitrogen-rich, which is why we need to mix in carbon-rich materials such as grass, leaves, sawdust, straw, and other animal manures. Food scraps can also be added to the humanure compost pile, and they already usually have the proper carbon to nitrogen ratio. We also cover the compost pile to keep in moisture in the desert, but that's not necessary in wetter climates. Compost piles need oxygen because we want to cultivate aerobic bacteria.
At Ampersand, here's how our composting toilet system works. First, you make your deposit. We collect both urine and feces together because urine gives the pile necessary moisture. Cover with a cover material, we use sawdust, which takes away any smell and adds carbon to balance the carbon-nitrogen ratio. When the buckets are full, we bring them to the main compost bins. We then line the composting bin with straw, create a hole in the center of the compost pile because it's the warmest part of the compost pile, and then we delicately dump our filled buckets into this hole and then cover it all with straw again. The straw acts as both a cover material, preventing smell, and it creates air pockets that insulate the humanure from the sides of the bin so it stays warm. Once we're finished dumping, we rinse out the buckets with water, dumping the dirty water into the compost. A final rinse of vinegar can then be used to fully clean the buckets. Be sure not to dump this vinegar into the compost. Thermophilically composted humanure sits for at least a year until it's ready, and low-temperature composted humanure matures for at least 2 years. When you're ready to harvest your humanure, separate the sawdust, humus, and straw to reuse it again in the composting toilets. Now you can use the humus to help plants grow! If you're worried about pathogens, you can use it for horticulture, for growing flowers, or growing trees.